Welcome to the UGC EPG Pathshala lecture series in computer science. In this series of lecture, we have been looking at software engineering. This will be a continuation of requirements engineering session, and I will continue with the same list of objectives where we are about to understand on the requirements engineering process. Now we are at the initial phase where it is requirements elicitation phase. So we will try to gather all the requirements that the stakeholders are about to provide us. Some of the challenges that we might face during this requirements elicitation process is three endemic syndromes. One is yes but syndrome, which is nothing but the stakeholders are about to say, if you pose them a question, they will come out with an answer of yes, that is what is required, but in a slightly different format. So they are not very sure of the, or rather to put it, they are not very consistent of what they exactly require, but they will put it as yes but, so it becomes a syndrome. The second problem that might affect us is undiscovered ruin syndrome, which is nothing but the search of requirements is like a search for undiscovered ruins. So we try to find more, the more we find, the more remain. And the third type of syndrome will be user and the developer syndrome, where the communication gap between the user and the developer starts building. So we may have to think of those syndromes and we may have to avoid as much as possible. Talking about the types of data, as and when we try to collect different data from the stakeholders, talking about the type of data, data could be of two different classes. One is called a qualitative versus quantitative data. The other one would be a structured and unstructured data. If you look at this figure, with qualitative data, if you ask people with qualitative data, they will give descriptive information, where I drink coffee every day, or I like to have a coffee, very good coffee every day. That becomes a quality information. Whereas when I want it to be quantitative, that means how much, specify in numbers, it becomes either discrete or continuous. Discrete means I can count on the numbers. So I drink 4 coffees every day, where 4 becomes one of the quantity. And by continuous, which can also be measured, I drink 80 grams of coffee every day. So that becomes there expressed a value which can correctly specify on the quantity. And the second type of data would be a structured versus unstructured data. If you look at structured data, it will be put as columns and rows, where high degree of organization would be there, and this will be represented in tabular format, relational database format, where I will represent all the details in terms of columns and rows. So column might take patient value, date of birth, date in which he got admitted, and the values, appropriate values will be mentioned. When it is supposed to be an unstructured data, it is all complete description that will be available. So this information that is difficult to organize using traditional mechanisms. So they try to think, they try to write a lot of words about a particular patient, then it becomes a complete of history, and this history is not structured also, or it is not organized also. So this becomes pretty much difficult. So we may have to at times convert this unstructured data into a structured data format, so as to make it more effective in terms of development. So what are the various methods by where we can collect data? The first ever method would be conducting an interview. So by interview, I will ask different community of people, and what is a suggestion about, I will conduct interview with different stakeholders, with different level of stakeholders, and try to get their opinion on how it is to be developed. Basically, because of interview, the system can have both positives and negatives, pros and cons. So talking about the advantages of this interview based mechanism, this interview gives us a rich collection of information. It uncovers opinion, feeling, goal, as well as hard facts. It can review in detail and adapt follow-up questions to what the person tells you. And at the same time, it has several disadvantages, like large amount of qualitative data can be hard to analyze. At times it can give you an information. By interview I can give you an information like 74% of the projects got failed, say way back 20 years back, and 47% has passed, so thereby we see a large difference. So these quantitative value and some qualitative value would not have a clear justification for us. So not as many people from various parts of the company are interviewed because of cost, so there exists high possibility of a bias. Usually many follow-ups are required for clarification. To the same person we may not be in a position to interview, because at times we may have wanted more of clarity, so we are not able to find the same person for getting a clarity on the same information. Interviewing is difficult to master. So the other methods of collecting the data would be like posting a questionnaire. Today we have got Google Doc, where whatever question that we wish to ask, and we can build up our own data sets by providing or by mailing it to different community of people with those questions mentioned. So questionnaire can be easily brought up. And background reading, understanding the background of such product, a survey can be done by where I can collect a lot of data. Introspection, social analysis, I can even do brainstorming, I can do storyboarding, I can develop a prototype, I can have a role playing, which is majorly being done at the Scrum level, where at every sprint there will be discussions that will be coming up. So one person will act as the leader for that particular day, and he will try to express whatever that he wishes to do. So there can be a role playing activity, and requirements reuse can also be done. Some of the methods for requirement specification include, so this requirement specification will be appropriate when the description is in natural language and it is not too complex, and it cannot afford to have requirements that is misunderstood. So the methods like providing everything in terms of a pseudocode, finite state machines, decision trees, object oriented modeling, entity relationship models, and many other methodologies would give a clear understanding to the stakeholders on what is to be developed. So we can just sketch a diagram, making ourselves very comfortable on understanding those requirements. So what does a pseudocode mean? So this pseudocode attempts to combine the informality of natural language with the strict syntax and control structures of a programming language. So it is an imperative sentence, a limited set, typically not more than 40 to 50 list of instructions, of action oriented verbs from which sentences must be constructed. Decisions are majorly represented with the formal if, else, end if structure, and iterative activities represented with loops like do while or a for loop. So this is how we draw a flow chart, and we have a pseudocode by the side of it. So I have a flow chart here wherein I have clearly described in a diagrammatical format, say start, put tea in bag and cup, boil the water, water becomes boiled, put water in the cup and add sugar to it, you can add milk, need to stir, and then that becomes a coffee. So within that you can have some loopings also. So converting that into a pseudocode will initially fetch me with a program for making a tea, where put tea bag in the cup, that's becomes the first statement. Why? Because this involves a lot of looping, I will put I'm just converting that into a while statement. While water not boiled, then you try to boil the water, and while pour water in the cup, while sugar not needed, add sugar, and while milk not needed, add milk, and while not to stir the tea, and while, and finish the task. So this is how I translate all these simple things that I have noted down diagrammatical format into a pseudocode. Not only that, I can even have a finite state machine where I can switch between states. This finite state machines are supposed to be machine state that can be in only one of a given number of states at any specific time. If I travel by my car, I can be at only particular state. I can either go forward or go straight, turn right, turn left, or take a U-turn. So those are the possible states. All at the same time I cannot do. So that becomes finite state status. In response to an input such as a data entry from the user or an input from the external device, the machine changes its states and then generates an output or carries out an action. Both the input and the next state can be determined exclusively on the basis of understanding the current state and the event that caused this particular transition. In that way, the system's behavior can be said to be deterministic. So, to understand better on the deterministic state or the behavior of the system, as I have pointed out in the functional parameter or functional requirement state, we draw this finite state machines. As a specific example, state 0 I will be in the drive straight mode. State 1 I am changing my state from drive curving left and forgetting about the sensors. If I am turning left, then I am moving to one other state, and if it is a right signal, then drive curving right, forget about the sensors. So these are the three states that is possible, and when time ends I will go back to the actual original state. So there can be third mechanism wherein I will have the requirements done. One other method is the decision tree construction. This decision tree is basically on if then else type. It can be basically a binary decision tree, or it can be an if then else decision tree. Requirements that deals with a combination of inputs, different combination of those outputs lead to different behaviors or outputs. So the combination of if then else clause quickly becomes twisted, especially if, as in this example, it involves nested ifs. So I switch between customer support decision tree where I have a state like this. I have a dissatisfied customer complaining or don't complain on a service representation, or a dissatisfied customer, I continue as a dissatisfied customer, or a service representation, I have a problem solver and I have one other person called problem unresolved, and further the customer seems to be dissatisfied. I have to escalate the problem or give up the entire problem as a dissatisfied customer. This seems to be like biased, or this seems to be like a binary decision tree where either the customer goes out of the loop as dissatisfied customer, or he raises up the issue, or his problem is being solved. So at the end only three states appear: either the entire problem is resolved, or the problem is being escalated and it is taken to the next level, or he moves out as a dissatisfied customer. So for reaching all these three states, I go up different states where it is all been binary. I have one other model which is called object oriented model, where the requirements involve description of the structure and relationship among entities within the system. It is often beneficial to use object oriented models to fully describe the behavior of the system. Why? Because it has got its class, it has got its inheritance, it has got its sequence, all that followed. So two separate representations that I have shown are between a sequential diagram and a class diagram. As far as sequential diagram is concerned, as a customer I lay down here, I log in, it gets on to the login screen, I validate the user which checks with the security manager, I have check user details which checks actually for the user, then the user details are being validated, the result is being produced to the customer. So this is how the process has been executed, so I draw a sequence for this. Likewise, I have one other diagram which is called a class diagram, which involves a person whose age is mentioned as integer and the get age as integer. So these are being inherited from either a student or a professor who has a relationship like 1 to 1. So these kind of representations would give us a lot of comfort, thereby representing the relationship between two different entities. So thereby we can clearly describe on the behavior of the system. So by these way of projecting this would be called as UML, which is Unified Modeling Language. One other representation will be on the entity relationship models. This entity relationship model is a data model for describing a database in an abstract way. Or I have to give a relationship between an employee and a department, then I put a relationship called works on. Employee works on a specific department, employee can be a manager, employee has a list of attributes, likewise department has a list of attributes and works on has a attribute. This entity relationship diagram provides a high level architectural view of the data. Thereby we are very clear what type of contact or what type of communication that this entity has with the other entity. So those are to do with the functional requirements. So whatever we have seen it as pseudocode, we have seen it as object oriented model, we have seen it as UML diagrams, we have seen it as entity relationship models, those are supposed to be mention the behavior of the system. Whereas when we look at the non-functional requirements of the system, we measure towards the quality issues. So some of the quality measures include whether the product that we have developed is correct, unambiguous, complete, consistent, verifiable, modifiable, traceable. If you look at the first 4 points, it majorly relates to almost the same factor, whether the product that I am trying to do is right towards this particular scenario or not. But then each and every point that we are talking about in this quality is of different understanding. When we try to understand on the correct requirements, which exactly means if the requirements are stated, represents something required of the system to build. When we talk about unambiguous requirements, these are subjected to only one interpretation. Requirements can be interpreted differently by the developers, users and other stakeholders. So when I try to match all the stakeholders' requirements on the same issue, then it becomes unambiguous. So I may have to adopt to only one strategy where I will be very clear what interpretation that everybody tries to provide. And about completeness on the quality measure, all significant requirements of concern to the user, including requirements associated with the functionality, performance, design constraints, attributes and external interfaces. So what is the system that is supposed to function, or what type of functionality the system is supposed to provide? Is it providing the same functionality that it has been proposed initially with? Then if it is said yes, it becomes complete. If the actual performance what was proposed in the initial has been performing, then it is yes. All the design constraints that has been met out with, if it is yes, then it is complete. All the attributes that initially that has been listed out by the stakeholder adopted, then it is yes. All the external interfaces that we were trying to collaborate with, if it is mapped exactly and within the stipulated time, then it is yes. So by where we are making the system more complete towards the development. The other point will be on the consistency. There will be no subset of individual requirements that describes within it are in conflict with another requirements. So there should not be any conflict between the requirements that the stakeholders have provided. So we may have to maintain consistency towards the entire phase of development. And whatever that we do need to be verifiable, testable. So create an appropriate test procedure to carry out the verification. So we should have appropriate mechanism to test every now and then, are we marching towards in the right direction with appropriate security and privacy mechanisms, so that we will have to reach the end. And at times towards maintenance also, and at times during the development phase also, if the system needs to modify, there should be a provision for modifiability. So any change of requirements that can be made easily, completely and consistently while retaining the existing structure and style of the set. So we may have to maintain the completeness and consistency without disturbing the structure of the system, we may have to modify on the entire project. That should also be possible. And in case if we feel there is some lag or there is some leak that is there left, then the system need to trace it appropriately. So the system should be traceable enough. So origin of each of its component requirements is clear, and if there is a mechanism that makes it feasible to refer to that requirement in future development efforts, then it should be traceable. Not only that, the major point that we may have to adopt towards this quality of a well formed requirement would be on the understandable. User and developer communities are able to fully understand the individual requirements and the aggregate functionality implied by the set. About the requirements validation traceability, IEEE in the year 1994 provided the compound definition of traceability, where they said ability to describe and follow the life of requirement in both forward and backward direction. So whether I march in the forward direction or I do it in the reverse direction, it should be possible. So if I do some things in the forward direction and it is not traceable when I come back, then it is not a worth of it. So traceability importance increases where the rate of change is so high. So some requirements are sometimes volatile. We have two different classes of requirements traceability. One is called forward traceable and the other one is called backward traceable. So when I am doing the forward procedure, I trace on the information a lot. So each input to a phase must be traceable to an output of that particular phase. So when I am working on the forward direction, I wanted to give an appropriate output which the user seeks. So for every type of input that is given to the phase, the output should be significant enough or more appropriate enough for the users. When it is backward traceable, each output of the phase must be traceable to the input of that particular phase. Output that cannot be traced to inputs are extra unless it is acknowledged that the inputs themselves were incomplete. So this is the way of traceability matrix, where for example I have given a list of features, feature 1, feature 2 up to n features, and the need that I require from all these features. So need 1 is for feature 1, need 2, need 3 are for features 2. So what I exactly do here is stakeholders needs are clearly mentioned, product feature is being given. So I trace from the product feature what the stakeholders needs are. So this is backward compatible. And I have listed out different features. For that I have given use cases, and use cases traces the product features. At times we may have to do requirements reviews also. Although we have collected all the requirements, sometimes it may not be feasible for us to develop the same quality product that we have been developing so far. So we may have to discuss among ourselves on the review of the particular requirement. So a group of people analyze the requirements, look for the problems, meet and discuss the problems and agree on the actions to address these problems. So review is very formal meeting headed by a specific leader. So there will be a leader for the team who will review on all the requirements that has been posted by different stakeholders. So not only to look for errors, but also check for the conformance of standards. As I have already indicated at the starting of this particular slide, this review is primarily for meeting out the standards that the development company has got. There should not be any deviation on the standard and providing a benchmark of the system. So as far as requirement review process is concerned, it has been executed in the following manner. I will plan for a review, I will distribute the documents, then I will plan for a review, hold review meeting, follow up actions and revise the documents. So initially documents will be distributed to all the participants. As a leader I will try to circulate all the documents. Then I will discuss on all the points that need revision. I will take up the follow up actions that has been suggested by the reviewers. Then I will try to revise the entire document. Thereby I am avoiding the gap, communication gap between the stakeholders and the user. Not only that, I am maintaining the standards that the development has to undergo. So, in this session of requirements engineering, we have seen what the requirements generally will do. Why are these requirements given so much of importance? Because we try to understand what of a system rather than how it is to be built. So, we get all the requirements from the stakeholder, we convert into actual format what they wanted. So, by where we are making ourselves very clear before we get into the development phase. So, that seems to be the very importance of the software requirements. Not only that, we have looked at the types of software requirements, we have understood the various skills and tasks that a requirements engineer need to possess. We have undergone a phase of requirements engineering process. We have told you about the methods for requirement specification, and we have specified on the quality in requirement specification. As far as methods are concerned, we have talked about object oriented methodology, where we have gone on developing UML use case diagrams, and we have plotted sequence diagram, we have plotted class diagrams. Not only that, several diagrammatic methods have been studied in this particular session. We have gone into entity relationship diagram mapping, where we have said the different entities can be mapped and the appropriate relationship can also be given. And the other point that we have discussed in this particular session is the quality of software requirements. When we wanted to have a requirement specification, if you are looking at the quality, then we may have to look at the completeness of the product. It should not be unambiguous, it should be very clear on what we have specified, it should be traceable, and all these things we have studied. And finally, we have said it has to undergo a review process with the help of a leader, whereby we are maintaining the standards that the development phase has to initially build up with. So, by where every product that we are trying to build, we are ensuring that the same level of standards is being maintained, so that we are about to deliver the same quality product. Thank you.